Cool.
Okay, ready?
Yeah.
Okay.
Just pretend like I don't have a camera strapped to my chest. So.
Okay, so here's the idea. So we were talking about isolating the tilt one way or another, and then we were thinking maybe that's still helpful to have the tilt.
Yeah.
But I was thinking the more that we can isolate, the better, and just how can we make this as easy for ourselves as possible.
Yeah.
So
when you say isolate the tilt, you mean like get rid of the tilt? Or
yeah, like we're talking about getting rid of the tilt, right? Just holding it vertical or horizontal.
Yeah.
But it might still be helpful to have the tilt, anyways.
Yeah.
So I'm thinking, how do we make this as easy for ourselves as possible?
Yeah.
So the idea hinges around. So this is the base plate.
Okay.
And this is the mounting plate. Okay.
Yeah.
So this is the equivalent of this.
Okay.
Where this mounts.
Yeah.
Okay, is this piece. So and these have a hinge. So these can just a free pinned hinge. You can just rotate like that.
Yeah.
And then the base plate is connected to the roller chains. Okay. So this moves along, and this has a hinge on it. So these move along together.
Okay.
And then if you just push on this, then it can move.
Yeah.
That's the idea. And so this would be here. That's basically that. So all the carriages that go along the roller chain would be this. Does that make sense?
Just give me a moment to do it. So, can we take this over here for a second? If you grab the. Base plate? No, base plate.
This is the mounting plate, and this is the base
mounting plate. Oh, blue still.
Blue still, yeah.
Okay.
So the idea being, the auger is still mounted to something that can hinge separate from the base plate.
Okay.
This base plate is what's connected to the roller chains. So this base plate can move, is what's being pulled along, and the mounting plate here is just attached to it by a hinge.
So you're saying multiple base plates, but they're not going to have these servos here because the tilt's going to be handled
A secret other way.
a secret other way. Okay, yeah. So
so just a free hinge.
Yeah, so more 3D printed parts, but not a big deal because they're just cheap 3D printed parts, no electronics, all that.
Yeah. So right now, just step.
Okay. Yeah. And then would tapping be?
So tapping.
Yeah, I'll let you. Let you keep going.
No electronics so far.
Yeah.
Just this base plate.
Yeah.
Okay. Can we get back over?
Which is basically like a carrier. Okay. Yeah. So kind of this.
But importantly, it has that hinge, so you can move back and forth.
Yeah.
So then, okay, put that aside for a second.
A hinge, but no electronics to be able to actuate the hinge.
You can move with your hand or something, but nothing.
And it's not going to stay. It's just like a free.
It's just a free pin.
Okay, sounds good.
Okay, so then underneath that, separate. This is static. So this is the carriage that goes along with the roller chain. This is would be like the scale is here. Just situated behind it.
Yeah.
That's where we have a little module that has. No, this is to scale, right?
Okay, sure.
But the stepper and the solenoid.
Okay.
Yeah. So the idea is if these can interface with that somehow, then we can move these carriages back and forth in a cheap way, and then have one stepper and one solenoid just interface with the auger, do the thing, and then step away.
So is the thought there, like, would you be taking this plus the stepper and maybe like doing an insertion and retraction of it, or?
Yeah, so this would all be on the underside. So this would have like a cutout or something. So this sits like flush with this.
Okay.
So this fits underneath. And so as this, so then this would be almost free floating, but then it would have like those cone connector things I was telling you about.
Yeah.
So it has like one of those in each of these corners.
Yeah, kinematic coupling.
Yeah.
I think is the.
Okay. I like that. That makes sense.
I learned about it from another open source project. Science
cool.
Jubilee was one.
Okay.
Tool changing,
Yeah.
So.
Yeah. Okay. Like kinematic coupling. So then, and then below that we have a linear actuator.
Okay.
Okay. So this can move up and down.
Yeah.
And this has something like just a pin as well. So it's just free floating in here. It can just move. And so then it maybe has like a little bit of some more kinematic couplings underneath, so it doesn't just like flop all over the place.
Yeah.
But it's like that. So the idea being that as this carriage moves over here, this linear actuator pushes this up, interfaces with the mounting plate, and then through a hole in this, then it pushes this up, and they move together on the tilt. And then when it's done, the linear actuator can pull a little bit back, and it releases, goes back underneath, and then this moves on to the next one.
Okay. So linear actuator from below gives you the tilt, which can fully disengage from the carriage, allowing for rotation with some massive stepper or planetary gearbox, something like that, going around. And then I think what I'm still not quite clear on is how the servo driving the rotation, the stepper motor driving the rotation, and the solenoid engage and disengage with the.
Yeah. So this base plate would have a cutout. So it's like a.
Okay, yeah, you're talking about the.
Yeah, maybe I can just cut it out real quick, actually.
Sure. The number of times I've looked for scissors in a lab context is ridiculously high. Yes, we do. We just need to buy like 5 scissors. Let's pause this real quick. You should have been more prepared for my impromptu.
This is my conversation with Will yesterday as well.
Yeah.
It's like, and then how does it work? And I'm like, okay, so the glove box moves this way, and then the random piece of paper moves this way. Okay. So this is the carriage, right? It sits like this. This can move.
Okay.
As it likes.
And this can't go beneath? Is that right?
No.
Okay.
So it sits here, but then it can freely move up and down like that.
Sounds good. Yeah.
So
and there's one of these per auger?
Yeah.
Is that right? Okay.
Yes, the auger sits on here, and this can move.
Okay, so this is like one repeatable unit
Yes,
right now.
Yes. This is end modules with this.
Yeah, and no electronics at all.
No
on this.
electronics at all. Yeah. Just the only mechanism here is that hinge joint. That's it. And then it connects, and then this is the part that connects to the roller chain.
Okay.
So this has like pins here, that connects to the roller chain.
Okay. Yeah.
And then it's like this, with this, all this together can move like that.
Yeah. Okay.
And then how it so this interfaces is as this moves over, it's pretty close. It's pretty close to this, but not touching.
Okay.
The bottom part.
Sure.
And so then the linear actuator moves up a little bit, and then we have the kinematic couplings.
Yeah.
That connect it with this.
Sure.
So these connect, and then the linear actuator as it continues to push, because we have that pin there.
Yeah.
Then it moves.
Yeah. That part makes sense.
Does that answer your question?
That part makes sense, but the solenoid and the stepper motor for the auger.
Or just like how they actually come together.
Oh, so I was picturing this only being the actuation for tilt. How is that also getting? Maybe that's the part I'm still missing. So like I think I get a linear actuator being here to engage tilt.
So the thing with the linear actuator, so we have kind of a second carriage that has all this stuff, and so this would sit like this.
Yeah.
And so as it comes over, it's almost engaging, and then as it pushes up a little bit, then it engages with the stepper motor there, and the solenoid like at another hole like right there. If that makes sense.
I think that does. So then, with that engaging is the idea that this would be held down only by the weight of itself.
I was gonna have the same clips that I have on that one.
Okay.
The compliant clips.
Okay. how would those clips, how would you get this into the clips without something constraining it from above?
Can we head over there really
Yeah, yeah.
So that would be like this. This is held by itself, right?
Yeah,
These kind
yeah.
of clips. So when you're first preparing the augers, you fill them up, you put them into the machine, you would lock them into this. This is on the mounting plate on the carriage.
I see, I see.
So these are all held in by these clips
Right.
the whole time until
Right.
the person takes them off.
And right now, this tap collar is fixed on there. Would you be like, oh, okay. So lifting, you would be lifting the solenoid up to the point where you can tap on the side of the
Yes.
auger. And you would also be lifting the stepper motor such that it engages with this.
Yeah.
Right?
So this solenoid would be here, like
Okay.
ish. These would be locked into that carriage.
Mhm.
This carriage is with the linear actuator would move up. It would engage with this and make it move like that.
Okay.
Makes sense?
I think so. Yeah.
And these would be underneath because this doesn't matter what orientation.
Yeah,
you're in,
yeah,
right?
yeah.
These would be underneath, and so as they come up, then you're close enough that the
Mhm.
solenoid can hit, stepper can move it together, and they're held just by those kinematic couplings and gravity, and there's
Mhm.
maybe some light magnets or something as well, and then they move together up and back,
Yeah.
and then it disengages, and then the carousel.
Okay. And with the, so we don't have servos here anymore. That can probably allow us to decrease the width.
Mhm. Yeah.
The that, so like this being clipped in, I'm sure we could design it so that well, basically, like, I'm not too worried about this coming out of the clips, but in pushing up to get enough of a clearance, getting the right distance between the two,
Yeah.
the two companion gears, would require at least some force to keep it. Is the roller chain, I guess, is going to take that opposing force to keep. It's like this is going to have to get lifted up
Yeah.
against the clips, or
Yeah.
like there's going to be some force that then gets carried by the
Yeah.
roller chain.
Yeah.
itself, right?
Roller chain. We could also have it so that that specific section has more. The roller chain is up against. It's called a wear strip.
Okay.
Or something like that. So it's pushing against some other like standoff that we have or something
Okay.
like that.
Yeah.
Yeah. So that's
Okay.
not just the roller chain, but like it's fixed in something.
Yeah, I gotcha.
Yeah.
Oh. I think I get the idea.
I'll model
cool.
it. I'll show it to you, and then make some kind
Okay.
of.
Yeah, sounds good.
But I think I was talking about it yesterday. I think it's the simplest way I've come up with so far to get it all.
Yeah, of having the tilt separated from the electronics, basically, right?
Yeah. Yeah.
Cool.
We don't have to have an arm that grabs something and moves it over or something like that. Like it's just, it stays where it is the whole time.
Yeah, that's right. It really just becomes there's no transfer of auger.
Yeah.
It's just getting the auger into position.
Yeah.
Cool.
Yeah.
I like that. Yeah, thanks for explaining that.
Yeah.